Hello friends, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 6 video on the chapter of parallelograms, where I will discuss about the geometrical figure of rectangles. I will discuss about its properties and the necessary conditions of any geometrical figure to be a rectangle, and will solve few problems based on the properties of rectangles. If you have not watched the previous 5 videos, part 1 to part 5, where I have discussed about in general about quadrilaterals and quadrilaterals and squares, and solved a problem from in assignment 1, then I strongly suggest that you watch those videos also to maintain the continuity of your study on the chapter of parallelograms. So this video is part of the playlist CBSE Maths for class 8, following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with part 6 video on the chapter of parallelograms, where I will discuss about rectangles. Okay, so I have prepared my rough notes on the right hand side, and I have a few problems at the end where I will solve the problems based on the properties of a rectangle. Okay, so let's start. So what is a rectangle? A rectangle is a special type of parallelogram whose every angle is 90 degree. So as you can see in the diagram, the figure ABCD is a rectangle, and since it's a parallelogram, its opposite sides will be parallel. That is, AB is parallel to BC, AB is parallel to DC, and we have AD is parallel to BC, and also since it's a parallelogram, the opposite sides the pair of opposite sides will be equal and parallel. So we will also have AB equal to DC, and AD is equal to BC, and also additionally we must have every angle of the parallelogram has to be equal to 90 degree. So this means that angle A, all the angles, that is angle A, angle B, angle C and angle D, they all must be equal to 90 degree. That is, all the angles are one right angle. So in a parallelogram, if you have all the angles are 90 degree, then it will be a rectangle. Okay, now let's see in more details what are the properties of a rectangle. Given a rectangle, what can we say about its sides, its angles and its diagonals? The first thing is that since a rectangle is also a parallelogram, opposite sides will be equal and parallel. So we must have AB should be equal to DC, and AB is parallel to DC. So we have AB is equal to DC and AB is parallel to DC. So this is one pair of opposite sides. The other pair of opposite sides is BC must be equal to AD, and BC must also be parallel to AD. So we have BC is equal to AD and BC is parallel to AD. This property is basically coming from the fact that it is a parallelogram. Property number 2 is that every angle of a rectangle is 90 degree. So we have this is 90 degree, this is 90 degree. Every angle, there are 4 angles in a rectangle since it's a parallelogram. So we have angle A is equal to 90 degree, angle B is equal to 90 degree, angle C is equal to 90 degree, and angle D is equal to 90 degree. Okay. Property 3 property 3 and 4, property 3 is very important and also property 4 is also important. Property 3 says diagonals are equal and bisect each other. Remember that in a parallelogram, the diagonals need not be equal, they can be unequal. But in a rectangle, the diagonals are always equal and also they bisect each other. So if you draw the diagonals, we have the diagonals in the if ABCD is a rectangle, then we have the diagonals AC and BD. Let these diagonals intersect at the point O. Since the diagonals will be equal, so we must have AC is equal to BD. AC should be equal to BD. Now the diagonals will also bisect each other. So this means that AO will be equal to OC and OD will be equal to OB. So we must have AO should be equal to OC and OB should be equal to DO or OD. Okay. The next is that each side forms an isosceles triangle with the point of intersection of the diagonals. So if ABCD is a rectangle, if you draw the diagonals, AC and BD are the diagonals, let the diagonals intersect at the point O. So it says that each side forms an isosceles triangle with the point of intersection of the diagonals. So let's consider the side AB. So the side AB will the isosceles triangle formed on the side AB is triangle AOB. This will be an isosceles triangle where this angle will be equal to this angle. That is, we will have OAB will be equal to angle OBA. Also, vertically opposite to the triangle AOB, we will have on the side DC, we will have the isosceles triangle DOC, where we will have this angle should be equal to this angle. So we must have angle ODC should be equal to angle OCD. Also we have on the side, I don't have space, let me create some space. Okay. Also on the side BC, we are having the triangle, isosceles triangle created is BOC, where this side, this angle will be equal to this angle. So angle OBC will be equal to angle OCB. And finally, on the side AD, we will have the isosceles triangle AOD, where this angle will be equal to this angle. That is, angle OAD should be equal to angle ODA. So this is also a very important result in a rectangle. At every side, each side will create an isosceles triangle with the point of intersection of the diagonals, and the two angles that is made by the diagonals at two opposite end of the sides of a side will be equal. Okay, so these are the major properties of a rectangle. Now let's see what are the necessary conditions for a quadrilateral or a parallelogram to be a rectangle. Necessary conditions for a quadrilateral to be a rectangle are, you can consider there are two possibilities. There are two so the one possibility is that in the first possibility, let's say this be first one, it has two mandatory conditions. So in a quadrilateral, if the diagonals are equal and also the diagonals bisect each other, then it has to be a rectangle. So in a quadrilateral, if both A and B are true, that is diagonals are equal and also the diagonals bisect each other, then it will be a quadrilateral. Or the possibility 2 is that it has one condition: all the four angles each measure 90°. In a quadrilateral, if all the four angles are found to be 90°, then it will also be a rectangle. Okay. Now, what are the necessary conditions for a parallelogram to be a rectangle? You know, our given figure is a parallelogram. Now, on top of that being a parallelogram, if you know that the first condition is that, first possibility is that if you know the diagonals are equal, in a parallelogram, if you find the diagonals are equal, then it will be a rectangle. It will be a rectangle. Why? Because you see for a quadrilateral, the first possibility, the two mandatory conditions was diagonals are equal and diagonals bisect each other. Now, if it is a parallelogram, in a parallelogram, the diagonals always bisect each other. So, condition B is already satisfied. So, we just need to have condition A, that is diagonals are equal. So, in a parallelogram, if we see that the diagonals are equal, we can immediately say it is a rectangle. The other possibility is that if in a parallelogram, if you find the one angle is 90°, automatically it will imply that all other angles has to be 90°. Using the using the fact that opposite pair of angles in a parallelogram are equal and the sum of adjacent pair of angles in a parallelogram is 180°. Using these two facts, you will see that if one angle is 90°, all other angles will also be 90°. So if all the angles are 90° and parallelogram is obviously a quadrilateral, then it will become a rectangle. And the third possibility is that if in a parallelogram you see that one pair of opposite sides are one pair of opposite angles are supplementary. If one pair of opposite angles are supplementary, this will also mean that all the angles are 90°. Because the pair of opposite angles are equal and if their sum is 180°, it will imply that each opposite angle is 90°. And if one pair of opposite angles is found to be 90°, definitely the other pair of opposite angles has to be each 90°. So, for a parallelogram, we have three possibilities. The first possibility is that if the diagonals are equal, then it will be a rectangle. Or if we find that one angle measures 90°, then also the parallelogram will be a rectangle. And the third one is that if we see that the sum of any one pair of opposite angles is 180°, that is one pair of opposite angles are supplementary, then also the parallelogram will be a rectangle. Also notice that a rectangle is also a parallelogram but not a square or a rhombus. We have already studied square but not rhombus. In a square we know that in a square we know a square is also a parallelogram where all the angles are 90°. But remember that in a square the diagonals bisect each other at right angles. In a rectangle the diagonals need not bisect each other at right angles. But in a rectangle the diagonals will be equal and they will bisect each other but not necessarily bisect at right angles. So this is the only difference between a rectangle and a square. Obviously a square has all the sides equal and the rectangle has only the opposite pair of sides equal since it's a parallelogram. Okay. So this was all about the theoretical concepts about the geometrical figure of a rectangle, its properties and the necessary conditions for a quadrilateral or a parallelogram to be a rectangle and its relation with the parallelogram, square and rhombus. Now let's solve few problems. Okay. The first problem says that ABCD is a rectangle whose diagonals intersect at O. Okay, if OD is equal to 5x plus 1, if OD is 5x plus 1 and OA is equal to 4x plus 19, then value of x is. So the measurement of the side of the segment AO is given to be 4x plus 19 and OD is given to be 5x plus 1. How can we find the value of x? Definitely there has to be a relation between AO and OD, that is the length of the segment AO and OD. Now we know that since it's a rectangle ABCD and we have the diagonals are intersecting at the point O, definitely these two angles will be equal from one property of the rectangle that we just studied. These two angles will be equal. Now this means that this side has to be in the triangle. So we can say that in ABCD, in rectangle ABCD, triangle AOD is isosceles where angle OAD is equal to angle ODA. So this will imply that OA will be equal to OD. So this again will imply AO is given to be 4x plus 19. This should be equal to OD and OD is given to be 4x plus 1. So we get a linear equation in x. So this will imply if I transpose all the x terms to the left hand side and all the constant to the right hand side, I get 19 minus 1 is equal to 5x minus 4x. So this will imply that 18 is equal to x. This implies that x is equal to 18. So the value of x is 18 and hence the correct choice is D. D is the correct choice. So this was based on one property of the rectangle, that each side of a rectangle creates an isosceles triangle with the point of intersection of the diagonals, where the angles made by the diagonals at the opposite ends of a side are equal. As you can see, we will also have this angle will be equal to this angle, and also this angle will be equal to this angle, and similarly we will have for triangle AOB, the angle ABO will be equal to angle OEB. Okay, let's do the next problem. It says that ABCD is a rectangle. ABCD is a rectangle. Line DE intersects AB at E. Okay, such that angle DEA is 66 degree. Line CO intersects DE. Line CO. It should be actually segment, not line. DE is not a line. This should be line segment. Line segment. So line segment, the line segment CO is also a line segment. Line segment CO intersects DE at O such that angle OCB is 43 degree and angle COD is M degree. Then value of M is. So from this diagram, I think the diagram is quite clear. We have to find the value of M. Remember that we have to find the value of M. The value of M will not be a degree. It will be simply a number, since the angle measure of the angle is already given as M degree. We have to find M. Okay. We have to utilize the given angles. Okay. So we will. So this angle is given. So we know that angle C, since it's a rectangle, angle C is equal to 90 degree. This will imply that what is angle C? Angle C is angle OCD plus 43 degree is equal to 90 degree. So this will imply angle OCD is equal to 90 degree minus 43 degree. This is equal to 47 degree. 47 degree. So this is 47 degree. Okay. We have to find M. We have to find M. Okay, fine. Also, okay. Also, in triangle, in triangle ADE, we know that angle, using the angle sum property, we can say that angle DAE plus angle ADE plus angle DEA should be equal to 180 degree. This implies what is angle DAE? Angle DAE is nothing but this right angle, that is the angle A of the rectangle ABCD. So we have angle A plus what is angle ADE? ADE is this angle. So we have angle ADE plus angle DEA. DEA is given to be 66 degree. We have this is equal to 180 degree. Okay, so this implies that angle A is 90 degree plus angle ADE plus 66 degree is equal to 180 degree. This implies angle ADE will be equal to 180 degree minus it will be minus 90 plus on the left hand side. 90 plus 66 is 156. So we have minus 156 degree. This is equal to 24 degree. Angle ADE is 24 degree. So this is 24 degree. Okay. Now, so what will be it is asking the angle M. There are many ways of solving this, solving the value of M. I'm just following one such method. So once I have angle ADE, I will know what is this angle. This angle. So angle angle ODC will be equal to 90 degree. Now, what is angle D? Angle D is equal to 90 degree. Angle D is one angle of the rectangle, so it should be 90 degree. Now, what is angle D? Angle D is nothing but angle ADE, which is 24 degree, we have already found, plus angle ODC is equal to 90 degree. This implies angle ADE is 24 degree plus angle ODC is equal to 90 degree. So this implies angle ODC is equal to 90 degree minus 24 degree, which is equal to 66 degree. So this is 66 degree. Okay. So now again we can easily now find the value of M, because in the triangle ODC the sum of the angles will be 180 degree. So we can say that in triangle ODC, we will have we will have m degree plus 66 degree plus 47 degree should be equal to 180 degree using the angle sum property of a triangle. So we can now easily find m degree is equal to 180 degree minus what is 66 degree plus 47 degree? It is 113 degree, which is equal to 67 degree. So m, the value of m should be 67. So this implies m is equal to 67. Now there are many other ways of solving the problem using any other properties. So the answer is choice D. For example, we could have used the quadrilateral OEBC. So this is right angle, and we have in the quadrilateral COEB, in this quadrilateral we know that its interior, sum of its interior angles will be equal to 360 degree, and we already know we can find this angle. This angle will be 180 degree minus 66 degree. So we can find this angle. So this angle will be 180 degree minus 66 is 114 degree. So this is 114 degree, and this is 90 degree. So we can easily find the angle COE from that is the angle O of the quadrilateral COEB. So once angle O is found in the quadrilateral COEB, we can easily find m, because the angle m and the angle O of the quadrilateral COEB, they are linear pair of angles and their sum would be 180 degree. So that way also we could have find the value of m. Okay, let's see the next problem. So PQRS is a rectangle. And we can see their diagonals are intersecting at the point O, where it is given PRQ is x degree. PRQ is x degree and POQ is y degree. Then which of the following is correct? So all the choices, relation between x and y are given. We have to select the correct relation between x and y. Okay, now clearly okay. Okay, so we know that from the property of the rectangle that on each side we have isosceles triangle formed with the point of intersection of the diagonals. So definitely this angle will also be x degree. So we can say that in isosceles triangle QOR, we know that angle OQR will be equal to angle ORQ, which is given to be x degree. Okay. Also consider the isosceles triangle on the side PQ. We have in isosceles triangle POQ, we will have angle OQP should be equal to angle OPQ. Now what will be these angles? Now the sum of these two angles is this. Also we know that also using the angle sum property in triangle POQ, we know that angle OQP plus angle OPQ PQ plus y degree is equal to 180 degree. This will imply that since angle OQP and angle OPQ are same, we can say twice of angle OQP plus y degree is equal to 180 degree. This implies we can say angle OQP will be equal to, there is no space left, we can say this will imply that angle OQP will be equal to 180 degree minus y degree divided by 2. So, angle OQP is 180 degree minus y degree by 2. Okay. We also know that in rectangle PQRS, we know that every angle of rectangle is 90 degree. So, we know that angle Q is 90 degree. What is angle Q? Angle Q we can say is angle OQP plus x degree is equal to 90 degree. This implies what is angle OQP? Angle OQP is 180 degree minus y degree divided by 2, and we have plus x degree is equal to 90 degree. So, somewhat we got a relation between x and y. We need to simplify this further. Okay. So, we have this. So, we have 180 degree minus y degree divided by 2 plus x degree is equal to 90 degree. This implies if we simplify the left hand side, we get 180 degree minus y degree plus 2x degree divided by 2 is equal to 90 degree. Now, doing cross multiplication, we will get 180 degree minus y degree plus 2x degree is equal to 2 multiplied by 90 degree, which is equal to 180 degree. 180 degree we can cancel out from both the sides, and we get minus y degree plus 2x degree is equal to 0. This implies 2x degree is equal to y degree. This implies x degree is equal to y degree by 2. So, x degree is equal to y degree by 2 is the correct relation, and hence choice B is the answer. Choice B is the answer. Okay, so that was 3 sample problems based on the properties of rectangle, and of course some other fundamental concepts of angle sum property or properties of angles and lines and angles, all those things. So, this brings to an end in the discussion of the rectangles, its properties, its necessary conditions for a rectangle, for a quadrilateral or a parallelogram to be a rectangle, and some few problems based on its properties. So, I hope this video was beneficial. If it is so, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video I will discuss about rhombus, and after that is complete I will discuss about trapezium, and that will complete all the special quadrilaterals, and then I will solve the 2 exercise problems of the 2 exercise from the textbook of author RS Aggarwal. So those videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.